Hey folks, when I first got my machine a few years ago, I remember both being excited and a little lost trying to figure it all out. I managed to get everything put together and actually working, but then I was a little stumped as to where to go next. I cruised through the forums for answers, but everyone there seemed obsessed with how to make the machine do things faster. I was still kind of stuck back in the do things part of that conversation. I needed to understand what the machine could do and how. This led me to create a number of what I called ouchie boards. These were just test boards where I made a number of cuts with minor adjustments here and there to see what happened. The ouchie part comes when the machine and I have a difference of opinion on what I intended to do.
That really wasn't what I wanted to do.
One of the first things these boards taught me was that which side of the line you cut on makes a huge difference. It has to do with something called kerf. If you're like me and you come from a woodworking background, you're familiar with the concept of see the line, saw the line. You draw a line on a piece of wood, line your saw up, and cut directly on the line. As long as you do this consistently, everything works well. However, the saw blade by design removes a certain amount of material when you cut. This is called kerf. Depending on the width of the blade, the kerf might be a fair amount of material, but as long as you consistently cut to the line, your measurement should only vary by about half the width of your blade, or about a 1/16 of an inch or less. The CNC machine is a different animal. You have a machine that thinks in terms of thousandths of an inch. The size of the cutters varies wildly. The inside and outside cuts are very different. And what the heck is a V-carve actually doing? My solution for this was the ouchie board. This video should give you some of the insights that I learned, but hopefully with a little less ouchie. Okay, so this is a piece of 1/2" MDF. This is the stuff that used to be really cheap but is now like incredibly expensive. But I use it because I love all of you and I want you to be happy. So I've taken and drawn some lines on this using the CNC. If you want more information on how that's done, I'll put a link down in the doodly-doo. But what we're going to do here is, you can see we're going to do an 1/8" inner cut. So we'll use an 1/8" bit and cut inside of all these lines. Then we're going to do an 1/8" and we'll cut outside them. Then we're going to do a 1/4" inner and a 1/4" outer. And I want you to see how that affects each one of these shapes going forward. I'm also going to leave the dust collection off, which I don't normally do, but I want you to kind of just see where the bit's going. So hopefully that'll give some of you a better idea of what these particular kind of cuts are doing. Okay, so here's our test board. I have my 1/8" inner cut, 1/8" outer cut, 1/4" inner, and 1/4" outer. And you can see the kerf size is significantly different between that 1/4" and the 1/8" here. Another thing is the amount of time that these took. For example, the 1/8" inner and outer took about 26 minutes. The 1/4" inner and outer took about 8 minutes. So it's a significant time jump. The larger your bit goes, the quicker you can make it move without risking snapping that bit off. The other interesting things come as you zoom in a bit on what's going on. One of the things you can sort of see here in our 1/8 of an inch cut is when we cut to this inside, we round our edge a little bit here in these corners for this, right? When we make our outer cut, we're left with a very sharp looking triangle here. But again, you can see when the bit path makes that nice sharp corner here, the outside cut rounds like this. This is really more obvious when you move down to the 1/4 inch, right? You can very much see here's our inner cut, and that 1/4 inch bit just doesn't make it down into the corners here of this, or by far not the star here, right? So our inner cut is going just to the edge of our line, but it doesn't get down into corners very easily, especially with the bigger bits. Now, our outer cut, you can see this leaves us with a nice sharp edged triangle, right? A nice sharp edged star. Same for these. But you'll notice again on things like the numbers, even when we're doing an outer cut, there are these little places that the bit doesn't get into. And this becomes very important. Now the other place that comes into play is going to be fitting shapes inside of shapes. So here on our 1/4 inch, we cut inside. And then this one we cut outside. These were both 1 inch drawings, 1 inch circles. So this is a 1 inch hole and this is a 1 inch circle. So I can take this out and this should fit right in there. And that works perfectly well. Now you would think 1 inch square would fit into a 1 inch square hole. However, you'll quickly find out that that's not the case. And the reason is that same issue that we were having before. You notice that the edges fit, the sides fit, but those corners are where things get a little dicey. Let's zoom in to that. Okay, so looking at our hole here, you'll notice that there is some rounding here at the corners. And that's what's preventing our little cube here from being able to fit in completely and lock down. That's where that 1/4 inch bit came around and couldn't quite get into the corners enough. Even if we go down into our 1/8 inch, we still have that same problem. It's just enough roundness to prevent us from fitting these two pieces together. Now again, the circles would fit just fine because there's no corners for those to give us any problems. But the square, the triangle, the star, any of these complicated shapes are going to give us issues because those corners on the inside are going to be rounded. So that's our inner and outer contour cuts. There's another type of contour cut which cuts directly on the line. It's called a no offset cut, and this is what I'm using to draw the lines on the boards with the marker. I will also show you how this no offset cut can work with a V-bit a little later on. But right now, let's take a look at pocket cuts. Now pocket cut is similar to the inside cut that we're used to, right? In that it comes to the insides of the lines. But it also, instead of just coming around the edge, takes out all of this material in the middle. Almost if you could take this square and push it down with your hand. It's a very handy cut for a lot of things. The one thing you'll see in it is that because we're cutting to the inside of our line, we'll run into that same issue that we did before where the corners will get kind of rounded. But we can combine cuts. So on this one, what I'm going to do is I'm going to do a pocket cut on this with 1/4 inch all the way around, and then I'm just going to do an inner cut with the 1/8 inch, and the 1/8 inch will just follow the inside all the way around. That will give us the speed of our 1/4 inch doing the pocket, but the clean edge that the 1/8 inch leaves us. Now, the 1/8 inch bit can also get into a lot of other areas that 1/4 is not even going to touch. So I'm going to do a quick little pocket on these letters, right? And that'll just make them kind of recessed into the board. Another neat thing with pockets is that you can combine shapes. Now in this case, I've got two shapes, right? So when I pocket, instead of pushing the letters down, it's going to take all this stuff in the circle and push it down, and going to leave me these raised letters. I'm also going to do the same thing here, only I'm going to use the 1/4 inch to take out most of this, and then the 1/8 inch, instead of going inner, I'll go outer, right? So that will clean in the outsides of these letters, so I'll get nice raised letters on this, and it will be a lot quicker than this one is. So this one we're going to use that 1/4 inch to hog out most of the material. Then we're going to go around our letters with the 1/8 inch in order to get that nice clean shape that we want on these. And I'll show you how both of these look. Okay, so I stopped this one after my pass with the 1/4 inch bit, and you can see what we've done is we've taken out all of that space in here and all that space in here. And if you get close enough, you'll notice that these corners curve, right? So it's not really quite a square. You've got these rounded corners in here. Now you see it even more in something like this, where the 1/4 inch bit was able to get inside of here and inside of here, but it couldn't quite get into this portion of the end. So when we come back with our 1/8 inch bit, that's going to take care of the rest of these little bits here and here, right? Okay, so we've made our pass now with both the 1/4 inch and the 1/8 inch bit. This is just our plain 1/4 inch pass, and this is our 1/4 inch pass where we did the pocket and then we combined it with another cut to where we cut just the inside here with our 1/8 inch. And when you zoom in, you can see that these corners here and here are very, very different. Because we did that extra pass with the 1/8 inch, we've got a much sharper corner on this one. So if you combine cuts, you can get the speed of that 1/4 inch, but the precision of this 1/8 inch. And it's a very similar thing here. So between these two pieces here, this one was just a straight 1/8 inch all around, right? This one we did the 1/4 inch, the pocket. In this case, we did an outer cut around the letters, right? The outer cut around the letters was done with the 1/8 inch bit. That meant that this one took significantly more time than this one did, even though we had to change bits out. So for letters like this, you'll see that an 1/8 inch bit is just fine because you're not cutting a tremendous amount of material out like you are with this and this. So you've got some nice shapes here, and anything that's smaller than this is going to get ignored by that 1/8 inch. And you might have to go and do another pass with, say, a 16 around just the insides of the letters. So by combining bits and combining different cuts, you can get a lot more efficiency out of things like this that would normally take you a very long time. Okay, so now that we've seen our inner cuts, our outer cuts, and our pocket cuts, I'm going to use a couple of specialty bits and show you 3 more types of cuts. The first one is a contour cut that we sort of skipped over. And instead of going outside or inside, this one is a no offset contour cut. And what that means is that the bit will actually follow exactly the lines. So it won't cut to the inside or the outside, it'll cut directly on the line. This isn't particularly useful in most cases for flat bits, simply because it doesn't let you measure what you're cutting very easily, because you have to subtract the width of the bit, or half the width of the bit in this case. What I do find it useful for, though, sometimes is taking a V-bit like this and using it at a very shallow depth to draw fine lines. And this will let you draw some really nice fine lines, and I'm going to do all of this here with that basic no offset cut. And this is very different from a V-carve. The second section here is where I'm going to do that V-carve. The V-carve is a specialty thing that uses the lines and keeps the bit directly in between those two lines. You'll see it a little bit more after we do it. I'll show you some of the details on that, but it's a very different kind of cut. It also requires a closed line. I couldn't do a V-carve, say, on something like this that is just a single line. It wouldn't know what to cut in the middle of, right? So this one has 2 lines. It's a little difficult to see on this, and we'll be cutting in between those 2 lines for all of this pass in our V-carve. And again, V-carve will make a little bit more sense once I get it cut and then I show you what the bit's doing. The last thing I'm going to do is 3 different texture cuts. Now texture cuts are a little bit different in that they let you introduce some randomness to what you're doing and allow you to create some cool patterns for textures on things. We're going to do one with a V-bit. We're going to do another with a 1/4 inch rounded end mill, and then I'm going to do another one with this big 1/2 inch rounded end mill. And those cuts allow you to create kind of waveform effects. And there's some randomness to it and some interesting setup that we'll get into in a later video, but I wanted to show you what's possible with those here. Okay, so here we have our board, and these are our V-bit operations are done. This is our no offset, which just traces our lines, and you can see it's wiped out most of our lines going through there. Then there's our V-carve, which is cut between the lines, so you can still see where our original blue lines were here, and we've just cut in between them. And then there's our texture pass, which is done kind of a sort of random striping of this area of the wood. And let's take a closer look at these and I'll show you what each one of them means. Okay, so for our V-bit with no offset, we've traced along our lines, right? So we made a consistent pass here, almost like you're doing it with a pencil, right? And you notice it went ahead and it wiped out our blue lines here, so it went right over top of those and made our pattern, right? Same with these. Now the V-carve is a little bit different in that instead of going directly on the line, this one goes in between the lines. So you can see we've still got a little bit of our blue here. And what it's actually doing is it's using those 2 lines to determine how deep it wants to go. You can't see it quite so well in the finer details of this, but you can definitely see it in basic, and I'll show you what I mean. Okay, so with our V-bit here, you notice that we've gone in between our lines. So we get down a little bit deeper in between when our lines are farther apart, and when our lines are narrower, like say in this, we go up a little higher, right? So only part of that is the bit coming down and going in between those lines. The other thing you'll notice that's kind of cool is on the corners of things, like this eye, for example, the bit comes down, it's a certain depth, and then in order to make these nice sharp little corners here, the bit comes over and goes up in each one of these corners. So you'll see a slight ramping here in our cut, and that lets this V-bit make really nice crisp corners when it's cutting things. And that's part of how V-carving works. Everything goes between the 2 lines that you've got, and the distance between those 2 lines determines how deep that bit's going to go. So for the first of our textures, we used a V-bit, and you can kind of tell because what the texture does is it randomizes little scoops into your piece, right, in that shape. And you can control things like the direction of this, the various depths or height of this, how far the step over is, which means how far that bit comes over each time. And it provides some randomness and some variance in this so that you get sort of a textured pattern. Now you'll notice this one, because it's a V-bit, is very, very sharp, okay? Our depths are pretty sharp. Our little edges here, our ridges here, are also very sharp. That is part of just the V-bit shape. We're going to do 2 more textures over here, but we're going to use some slightly different bits. This one, we're going to use a round nose bit. And this is a 1/4 inch round nose, and it's got a round nose, as one would think. We're also going to do the same thing in this one, only we're going to use what's called a 1/2 inch round nose, or a 1/2 inch bull nose sometimes is what they're called. And we're going to see what the patterns look like with this. Now one other thing to note with patterns is, unlike say the V-carve or even our inner and outer offsets, the textures are quite happy to run right over your edges, and you can see this one did in several places. and part of that is just sizing the bit, and I guess the way, you know, Carbide decided it would be. So these kinds of things a lot of times will require a second pass to cut out the shape that you wanted and still maintain this kind of nice texture. This kind of texture, the sharp texture, would actually be good for something if you want, say, a tree bark effect, whereas I think these round noses are going to give us more of a wave effect. Okay, so you can see with our round bit, we've got a much more kind of a subtle feel than this, whereas that V bit is very pointy when it goes down. That round over bit leaves us with a slightly smoother looking bottom here, and I think if we adjusted this to where it wasn't quite so deep on some of the passes, we get an even subtler look to it than this. But this is almost a nice ocean wave kind of look, and I suspect when we put in our big half-inch round, we're going to get something even cooler than that. So let's chuck this bad right up and see what we got. Okay, so this is our half-inch round over bit, and you notice that's an even more subtle feel than this. Now, it looks like we missed a couple of places in here, and it may have just been that we didn't have quite enough height to go down into there where we wanted to. I can feel just the slightest bit of curve in there, so it may be if that actually hit it, it just didn't go down very far. So you can use these kind of patterns to create some very nice texture effects like water or sand or something like that, and it might even be interesting to try something like doing this kind of a subtle effect and doing this kind of effect behind it, or vice versa, and see how that looks. But again, these will give you some fun little textures for projects, and I think they're a very useful thing in a lot of ways, especially if you're making small stuff that people like to pick up. Textures like this can be a really nice thing because they're just one of those things that people want to grab it and explore it with their fingers and stuff, so they're very nice for craft shows and such. So my plan with this video is to make an extremely basic set of tutorials for CNC. We'll start here with what can be done on CNC. Next, we'll explore the Carbide Create designer and see how we can set up a new project, draw our lines and shapes, do boolean operations, edit nodes, and more. The third part will cover how we set tool paths, select and add bits, as well as preview and save our gCode. The fourth part will finish up by covering how to set up the machine for cutting, do bit changes, rapid positions, work holding, and repeatable cuts. I will likely alternate with some project videos just to keep things interesting for everyone. My hope is also to keep producing these videos a little bit more on a basic schedule. But, you know, of course, things are subject to change. But, barring a new pandemic, until next time, thanks for dropping by, and I'll see you again soon.